Today we're going to learn how to crash a network diagram. So here we have an exam question from 2013 and we have a network diagram shown here, and the question says the graph above shows 5 activities A, B, C, D and E that must be completed to finish a project. The number next to each letter shows the completion time in hours for the activity. Each of the 5 activities can have its completion time reduced by a maximum of 1 hour at a cost of $100 per hour. We need to find the least cost to achieve the greatest reduction in time taken to finish the project. And we have 5 options here. So we're looking to find the greatest reduction for the least amount of cost. So to begin this question, what we would want to do is find a critical path to begin with, so we're aware of the original completion time. That way we can then work on finding a reduction, the greatest reduction. So we can do forward scanning very quickly to find a critical path. So in the beginning, at the start, we start with 0. If I travel up along through activity A, it will take 4 hours to get there. Going through B from the start, it will take 3 to get to that vertex. Then to get to the vertex out here, there's 2 possible ways. I either go A and C for a total of 9, or B and D for a total of 10, and we always take the longest way forward. So the 3 and the 7 is longer than the 4 and the 5. Finally travel through E of 14 to finish with a completion time of 24 hours. So that's our original completion time. Okay, so I'm just going to make a note of this. Our CP, or our critical path, would be the longest way forward through the network, which will be B, D, and E for 24 hours. So B, D, and E for 24 hours. Okay, so that's the original completion time. So we now need to think about, well, what reductions can I make to get the greatest, what reductions of these activities can I make to get the greatest reduction for the least amount of cost? So one way we can do this is through this is something called a table method, which is what I've got on the right hand side here. And the way you work through the table method is to examine your graph and write down all the possible paths from the start to the finish. And this is a very simple diagram. There's actually only 2 possible paths to take from start to the finish. I could do A, C, E. A, C, E is one possible path from start to finish, and the other one would be B, D, and E. So only 2 possible paths from start to finish. So our first column in the table is where we write all the possible paths from start to finish. In the next column, we write down the completion time for each particular path that we've got in the first column. So we already know BDE takes 24 hours, so I can put that in to my table. However, ACE, I'll have to go back and look how long it would take to go through ACE. So A is 4, C is 5, so a total of 9. 9 plus the 14 will give me 23. So that particular path, the completion time would be 23 hours. So you'll need to do that for every single possible path you have in the first column. Now, let's go back and look at what we're allowed to reduce. So the question says that we can reduce each of the 5 activities can have its completion time reduced by a maximum of 1 hour. Okay, so each activity could be reduced by 1 hour. So in the next column of my table is I write down every activity that can be reduced. Now in this case it says all 5 activities could be reduced by 1 hour. So I've got a list of all the activities that could be reduced, which is A, B, C, D, and E. And I've also written the maximum amount of time I can reduce them by. So I've got a -1 next to all of them because they can be reduced by -1, by 1 hour at most. So I assume when I'm working through this, I'm assuming I am going to use the maximum reduction possible. So the 1 hour for each of these activities. So I go and apply these reductions to each path that I have in the very first column. So examining A, C, E, I can reduce A by 1, C by 1, and E by 1. All of those are possible reductions according to the table here. So what I do is I go and subtract, in this case 3, 1 for activity A, 1 for activity E, and 1 hour for activity C, I subtract that from the completion time. So I can actually make a reduction of A by 1 hour, C by 1 hour, E by 1 hour. That's a reduction of 3 hours in total. So the new completion time for that particular path would be 23 take away 3, and that would be 20. Okay, and I apply the same concept to all the other paths that I've got listed here. So my next path is B, D, E. I am allowed to reduce B by 1, D by 1, and E by 1. So I apply that reduction. So the path originally took 24. I am now reducing it by 3 hours in total. 1 for each of those activities, 1 for B, 1 for D, 1 for E, and I now have a completion time of 21. Okay. Now what I do is look for the critical path, the new critical path. So the original critical path was here, the longest way forward. After the reductions, the longest way forward is 21. Out of my possible options here, so I'm looking at a 20 and a 21. The longest way forward is 21, so that's my new critical path. So it's still remaining as BDE, which is ideally what we're looking for. We're not looking to change the critical path of BDE, which is one really important fact we need to know about crashing. So basically, we still need B, D, and E to be the critical path. We don't want to change the critical path. We can change the time that it takes, but we don't want to actually change the critical path. So we still want B, D, and E to be the critical path. And it still is, which is great. However, we're going to now need to figure out the cost involved in making this reduction. So the reduction actually is 3 hours. That's the greatest reduction we can do is 3 hours. Having a critical path of 24 and reducing it down to 21. Okay, so greatest reduction is 3 hours in total for a new completion time of 21 hours. Okay, that is the greatest reduction possible, 21 hours. which is a reduction of 3 hours. So now we need to examine how can I reduce my critical path. So looking back over here on the left side, the green critical path, how can I actually get that down to 21? That's my aim. How do I get it down to 21? It was at 24, but after the reductions in this table, it says I can get it down to 21. So I need to look at how that is possible. Then I can figure out the cost. So be very careful here. Don't just assume that you've reduced by 3 hours, therefore the cost will be $300, like $100 per hour. That's not the case. You do have to go and check how to make the reduction. So how do we get to 21 hours? Basically, that's what we need to think. How do we get there? Okay. So we now need to examine the graph. So I'm going to use a different color pen here on the side. Okay. So you'll notice across the top, to get to this vertex that I'm going to highlight in pink, that's a key vertex right there. Okay, where the 10 was, because that's a meeting point of the two particular paths. There was 9 across the top, 10 along the bottom. So if I was to reduce B or D by 1 hour, I would have 9 across the top and 9 along the bottom. So I would effectively have 2 critical paths, the one along the top and the one along the bottom. But because B, D, and E is still a critical path, we assume that there's no change in the critical path. Yes, there is another one, but the original BDE is still a critical path, and that's our aim. We still want BDE to be the critical path. So I can reduce, for example, D down to 6. Okay, then I will have 9 across the top, 4 and 5, 6 and 3, and I will have 9 here, and I will erase the blue ones from the original. We don't need the original one anymore. So that will get me to 9 plus 14, that will get me to 23. So by reducing D by 1 hour, I've now reduced my completion time to 23, but our aim is to get down to 21. Okay, so on the right hand side, I'm going to keep track of what I did. So we reduced D by 1, and that gives us a completion time of 23 hours. Okay, but our aim is to get down to 21 hours according to this table. So we need to make some more reductions. Now, if I reduced E, as you can see, E has to be on the critical path, no matter whether it's BDE or ACE. E is common to both of those paths, so it would be extremely effective to reduce that one by its maximum, which is 1 hour. So that's now 13. Okay. So if I was to move forward through the network, I'll have 9 across the top, 9 across the bottom. So we're assuming the D has been reduced to 6. So it's still 9 to get to that vertex, plus the 3 gives us 22 hours now. So that's a possible reduction. So we can reduce E by 1, and that gives us a completion time of 22 hours. Okay, and again, our aim is to get to 21. So I need to look at what else can I do in terms of reductions to get down to 21, because that's as low as we're going to get. So again, there's two paths only. So if I was to change A, C, or B, they're the only ones I have left to change. I'm allowed to change every activity and reduce it by 1 hour. So if I was to pick one of those, for example, A, and I reduced that down to 3, and now I went forward scanning again. Across the top I have 3 and 5, which is 8 to get to the vertex in purple, but around the bottom it's still 9, and we always take the highest number going forward. So I would still take the 9 plus the 13, which is still 22. So I can reduce A by 1, but it actually has no effect on the overall completion time. Okay, because remember our aim is to get to 21, and that didn't help get to 21. So I could reduce C or B next. Okay. So given that I crashed A and I have a total of 8 along the top, but a 9 along the bottom, to reduce the overall completion time, I need that 9 to actually come down by 1 to the number 8. So the only way that that's going to happen is if I reduce B down by 1 hour to 2, and along the top I will have 3 plus 5 is 8. Now along the bottom I have 6 plus 2, which is 8. Okay, and that's what I need. 8 plus 13 gives me 21. And I've now reached my target goal of 21 hours. So I needed to reduce B by 1. And I've now got the completion time down to 21 hours. Okay. So in a sense, in order to get the 3-hour reduction in completion time from 24 down to 21, there were 4 individual activity reductions that needed to happen to get down to the 21. So given that it costs $100 per hour for every activity or every reduction you make, my total was 4 reductions. So our cost, our least cost, would be 4 times $100, which is $400. And our answer is D. Okay, so it's very, very important that once you do this table method here and figure out what the lowest, what the reduction of time is, you will then need to go through your network and start making appropriate reductions. So crash those activities until you get to that required time, which was 21. Okay, so that's how we can crash this network that involves costs.